Hi guys, you are welcome. In the last previous lesson, we were able to calculate the pressure at the base of the tank. This pressure is what we are going to use now to analyze and design the reinforced concrete. And the pressure we calculated was 25.533 kilonewton per meter square. So we will be using this pressure to design a suitable reinforced concrete water stand. And so we will be choosing this kind of tank, okay, this kind of tank stand, single column. So in today's lesson we are going to model this, analyze and design this, applying the load that was calculated in this question. Okay, so that is what we are looking up to in this lesson. So before we start, I want you to like the lesson, subscribe, and take time to follow the procedures that are in the lesson so you can have a better understanding on how this is actually carried out. Okay, so let's start. I will create a new project. PS8110 I will import. Alright, so I will be using my orthogonal exit generator just like this. I want this place to be, this is the exit label A. Okay, so I want it to be like this, 1200. Why I wanted it to be 1200 is I do it so I can have a space for a walkway. Okay, if somebody get up to the height of the platform, you can have a space where the tank is being placed. Okay, that is why I'm providing this. Okay, so I will be having 1.2. Sorry, this place will be 2. Alright, just something of this kind. So if I click on it, okay, I'll be having something like this. Alright, so having something like this, the next thing we will do is we'll place column. Okay, so I click on column, and then the column manager, I want to use a circular column just like this. Okay, this is 400. I want to use the circular column of 350 diameter. Okay, and so I will place the column. Alright, let me use 300. Okay, place the column here. Alright, so I click on close, after which I will activate a beam. Okay, so I want to use a beam of 225, okay, by 450, just like this. Okay, so I'll click at this point and take it across to this point, and then I will escape. Oh, sorry, I click on this to undo this. Okay, so I pick my columns again. I placed it wrongly. Alright, so this is 300. Supposed to place it here, just like this. And for the beam, I will use 450 by 225, just like this. Okay, so this is what I expected to have. Okay, so I will want to place another beam again. Okay, so I will edit this time around. I want to use beam thickness 300. Okay, this is the way I felt I want to design this. Okay, so just follow the procedure. So I want to have this place to be 450. Okay, so just like this, 450. Alright, so after getting this, the next thing I'll have to do, click on closed. Okay, so I want to insert a slab here. Okay, you know the water tank is going to rest on this. Okay, so click on the slab. The thickness of my slab, I want to use 150. Okay, the load of my slab, let me choose this one, flat roof. Okay, or the imposed load since it's carrying something, I'll use this. Okay, and I will insert my slab just like this. Okay, so far let us look at in 3D what we have done so far. Okay, so I will navigate to the 3D, and then you'll be having something of this kind. Okay, so this is the water tank modeling. Okay, alright, so the next thing we'll be doing is to apply the load. Okay, but by then I want the height of this to be 3.5, so I will go and edit story. Okay, so in the edit story menu, I will change this place to 3500, just like this. Okay, alright, and for the foundation I'll leave it at this. Okay, click on okay, so this is it. I will navigate to the plan view. Okay, and I want to add my load here now, so then I want to save the project. Alright, so after saving the project, I will click on this this one. Okay, this one. So I want to be using this one. So but before I will use this one, I want to show you how you can apply this point load. Okay, directly on these columns. Okay, but we will do that later. Alright, so I will click on this point. Okay, I will click on this point, and then I want to change this place. You can see that is why I say this should be calculated in order to get the UDL per area. Okay, just as we calculated it. Okay, so you can see the unit here, this kilonewton per meter square. Okay, so we are having 24.533. Okay, kilonewton per meter square. So this is what we'll be applying to this. Okay, so I want to click at this point and then click here. Okay, to apply the load. So the load has been applied on this because this is the area that will be covered by the water tank. Okay, this is where it's going to sit. This is the base pressure, where the pressure is going to be fully applied. So if I navigate to the 3D, okay, so you can see the load has been within that specific area. Okay, so I will close this one. Okay, just like this. Alright, so the next thing we will be looking at is running the analysis of this particular structure. You go to the analysis tab, you activate the building analysis. Alright, so you go to the parameter. Foundation is 100. Okay, kilonewton per meter square, which is the allowable size stress. Okay, so the project title, this is a water stand. Okay, design. Okay, and this is soft. Okay, this is soft resin. All right, click on. Okay, so I'll go to load this. Okay, and then click on load generation, then select this and click on OK. I did add horizontal load. Okay, so click on OK. There is no need for me load. Okay, because the structure is not an high rise structure, so I cancel this. I want to edit the material. Okay, so columns, if you check the, let's say they say we should use FCU 25 and FY cost 410. Okay, the characteristic strength of concrete and steel 25 410. Okay, so we are going to edit this place. Okay, it's already at 20/25, so we'll be using this. Okay, this is the FCU. Okay, so this is the FY 410. Okay, so what we'll be doing now is we'll edit the bar. Okay, so we will choose for column Y 50, 16, 20 and 25. All right, and then for the slab. Okay, so we deal with we want Y10 and 12. Okay, just like that. Alright, so for the beam we will also choose 16. Okay, 20 and 25, just like this. Okay, so for the lengths, we'll be looking at 8 and 10. Okay, 8 and 10. Alright, just like this. Okay, so we'll go to the foundation. In the foundations we'll be looking at 12. Okay, and 16. Okay, alright, so we click on OK, just like this, and then you go to the building analysis. You check the building. If there is any error in the modeling, you check the structure. Okay, so you see building model check completed. The structure has been checked successfully. Numbers of error equals 0, so click on closed. Okay, you check this and this one. Okay, and then the next thing you do is start analysis. Alright, so analysis, building analysis completed successfully. Click on OK. Alright, so once you click on OK, you can go to post analysis and check the model. Alright, so this is the model. Okay, this is the model. You can see the formation due to that load. Okay, so if you check this animation, you will actually see the behavior of the structure, the water stand, how the load is compressing the structural element. Okay, so this is how it's supposed to be. Okay, so if you activate the diagram and then you check the bending moment, you have something of this kind as the bending moment. Okay, also if you check the shear force, you'll be having something of this kind. Okay, so this is how the shear force looks. Okay, and the bending moment. All right, so let's close this tab. Okay, we'll stop the animations. Close this. Okay. Alright, so we have done in the designs. Okay, so we can also click here to change the column if the column has actually designed. Okay, so you can see the column has been designed, and what we are having is a 6x16. Okay, so if you check the interactive design, uh, you will have something of this kind. Okay, so you can see the required area. Okay, equals to 7.35. Okay, supplied area is this. Okay, so everything is okay. So let's check the beam. If the beam has designed, click this point. So this is what we are having. Once you see it designed, check green, and okay, it means it has been designed. Let's check the reinforcement. Okay, so you're having this 2y16. So you can make it 3 for unforeseen for unforeseen cases. Okay, so can now close this for the sake of this lesson and the question. Okay, if you are in the examinations and you are asked to do this, what they required of you is they required your report. Okay, they require your report, so you just come to this place and create a report for this by clicking on this report tab, activate this one, and then click on OK, and then wait for the report to load. So you have something like this as your report. So this is your report. Okay, this is what you will be sending to the lecturer. Okay, you print this PDF or any other formats. All right, so you close this. Okay, and then close this one. The same thing likewise to columns. It is just the report. Okay, so you have to check print first. Okay, before you click on report. Once you click on report, check this one and this, then click on OK. All right. So this is what you actually have as your report. Okay, you can see the color here for design. Okay, so you just print this one and send it to the lecturer. Okay, now this is what you have design. Okay, so this is how it actually works. All right, so we want to close this one, and we'll close this. Okay, also we'll close this one. Okay, so now we will be designing the foundation. We want to use part footing. Okay, so click on this. Right click, and then you we okay, you before then, if you want to insert foundation at the 3D, okay, make sure the grid lines are at the foundation level. So double click, you have to bring the grid lines down. Then select the column, right click, and then you insert your part footing just like this. And then I want this place to be 350. Okay, which is the footing depth. Okay, and then select white wave and check if it will actually pass. Okay, if it passes, go by that. Okay, so click on calculate like this. You calculate, you're having a square columns, a square footing. Okay, the ls is 1100 by 1100 ly. So you check all of these points if they are okay. Yeah, they are okay. The spacing, okay, is 150. You can see, and then click on okay, and then okay again to apply it. Okay, so you have something like this as your foundation. Okay, all right, so this is how you design the single column tank stand based on that question. Okay, so I will click on to save the project. All right, so this is it. If you want to produce your drawing, okay, from this you can just easily come to this point and then you use this load prota detail. Okay, so this will be able to produce drawing for this for you. What you just need to do is to run the editing. Okay, all right, so this is the lesson. If you have not subscribe and be part of this lesson. In the next time we will be bringing to you another advanced lesson, so that you will not miss out. Hit on the bell icon and share the lesson as well. Bye.